Hello everyone and welcome back. We are continuing our look at solving rational equations from our unbounded online textbook here. And we already did exercises 1 and 2, so we're going to go ahead and jump into example 1 here. Now, we're asked to solve the following equation, and here we are. Okay, so how do we solve this? Well, again, there's a couple different ways we could do this. One option here is because we have a ratio equal to another ratio, right? A fraction equal to a fraction, is we could cross multiply here. So we could do 6 times x plus 3 and 12 times 5. When you multiply the 6 times the x plus 3 here, that 6 is going to distribute. So it's going to be 6x plus 18 when you multiply. And then 12 times 5 will give us 60. And now we can just solve from here. So subtract 18 from both sides. 6x is equal to 42. Divide both sides by 6. X is equal to 7. And there's our answer. An alternative way to do this is to recognize that, having common denominators can be helpful in fractions, so and rational expressions. So what would our common denominator be here if you look at these two fractions? What would our common denominator be? So again, typically we get common denominators when we want to add or subtract fractions. Well, here we're not adding or subtracting, we just have two fractions we're trying to compare. But it's helpful to have common denominators so that way we're comparing the same kind of thing, right? Here we're comparing twelfths with sixths, okay? They're not exactly the same thing. So let's go ahead and convert here to twelfths, right? That would be a good common denominator to use. So we'll multiply the right-hand side by 2 over 2. To get 12, since we get 10 over 12 equals x plus 3 over 12. We didn't have to do anything to this side, it already was in twelfths. And so now, to get rid of this divided by 12 on both sides, we can multiply both sides by 12 to kind of like clear out the denominator. And it leaves us with x plus 3 equals 10. And then we just subtract 3 on both sides. Sorry, getting ahead of myself there. Subtract 3 on both sides, and we get x equals 7. Voila, same answer, right? Okay, didn't ask us to check your answers here, so we'll just go on from there. All right, next problem here. Again, asked to solve the following equation. So, same kind of thing here. It'll be a little bit trickier here to get a common denominator. So let's go ahead and just cross multiply, okay? I will show you common denominator with this, but let's cross multiply first to see that. So again, distribute the 3 to both the x and the minus 2 there. So it'll be 3 x minus 6 equals, and then the x times the 8 will just be 8x. Okay, and now we solve. So we'll get our x's together by subtracting 3x from both sides. 8 minus 3 is 5x, and divide both sides by 5. And get x equals negative 6 over 5. And there's our answer. Okay, if we wanted to do this with common denominators, it would be a little bit more work. To get a common denominator here, right, we have to think back to our adding and subtracting, right? Compare our two denominators here, right? Both of them have an x, but this is an x minus 2. And we can't multiply this x by something to get a minus 2. So what do? Right, well, we'll have to multiply the left-hand side here by an x minus 2 over x minus 2. And we'll multiply the right-hand side here by an x over an x, okay? That way on this side, right, we'll have the x minus 2 that this denominator was missing, but this denominator had, right? And on this side over here, we'll multiply by an x because this denominator is missing just an x by itself, like this one has. Okay, so when we multiply here, again, distribute the 3, so it'll become 3x minus 6 over x minus 2 times x equals 8x over x minus 2 times x. And again here, because we have the same denominator, we can multiply both sides by that denominator, and that'll cancel those out, and multiply this side by that denominator, and that'll cancel those out, and we're left with just 3x minus 6 equals the 8x, which is the exact same thing we had up here to start out. Okay, so again, in these situations, there's no necessarily tried and true method of solving these the same way every single time. I mean, you can solve them the same way every single time, but you can see that different methods are faster or slower, depending on what you're trying to do. Okay, in the next video here, we'll tackle some of these other problems.